Hello to wherever you are joining us from today. This is Kevin Jackson from Trillio. I actually see a number of our regulars are back, so it's good to see you again. But thanks for taking the time out of your busy day to join us for another Ask the Experts series session focused on cloud-native data protection. Our aim is to provide relevant topics and discussions around various data protection challenges in a quick 30-minute lightning talk style format. We'll do our best to stick to the time frame. I say that, but we never do. Cloud native backup is our strong point, and clearly timing never is. As you can see, we've defaulted everybody to mute. John prefers it when he does all the heckling and shouting. But that said, we do want to keep it interactive. So use the tools you've got available to ask us questions. Certainly during the topics, please send me any questions you have and we'll get to them at the end. With that, I'd like to introduce you to John Tobin, who will be taking us through today's topic on the benefits of a cloud-native data protection approach. Fun fact, by the way, if you've not met John, do a search in jiffy.com, the animated GIF search platform. That's GIF, as in like people used to call it GIF, but we get told it's GIF these days. But go to giphy.com, search for John Tobin, and you'll see what I mean if you've ever met him. But without further ado, over to John with today's topic.
Kev, you always find new and inventive ways to heckle me. And speaking of heckling, just so we're all clear, whenever we go over, it's always Kevin's fault. And usually he's the one doing the talking. So I'm going to try to stick to time today. Anyways, let's get into the agenda. So we'll do a quick intro about the series like we do every time. We'll talk a little bit about how we got here. What brought us to kind of cloud and how did we get to having to change our backup paradigm. We'll talk a little bit about the cloud characteristics, some of the challenges of abstraction and the challenges that come with just being in the cloud in general. And then, application evolution, how it's changed with the cloud and the resources available. And then we'll talk about the benefits of backup integration, of course, because that's what we're here for. Then we'll go into some Q&A. But a little bit about Ask the Experts. So now we're doing this monthly. And it's a discussion on backup and recovery, a bunch of different topics inside of that. Interaction's always encouraged, so you can send Kevin your questions. Bring your challenges and concerns, right? This is an open discussion. So at the end, when we're going through Q&A, it's not just about questions, but if you're curious about something, please ask us. As always, the person that's most actively engaged wins a $50 Amazon gift card. But for today's discussion, the second most actively engaged person is going to get the British national dish, which I believe is chicken tikka masala, Kevin, but I guess it could also be like Yorkshire pudding with some sort of beef. And not only will it not be cooked by the Swedish chef, which we always love Muppet jokes, it'll be cooked by the original Muppet himself, Kevin Jackson, and shipped to your door via surface mail from Liverpool. Actually, of course, that's a joke, but I'm sure Kevin's great at cooking. So anyways, who are we? So that's the ever handsome Kevin Jackson right there. And he covers all the EMEA from a solutions architecture perspective for Trillio. Kevin's got a very extensive background. He's even written a book on Openstack, so he's extremely knowledgeable. My name is John Tobin. I cover all of the Americas. I've been around the IT industry for a while now, maybe even too long. But anyways, let's get into our discussion. So what really changed everything? Well, in 2006, Amazon kind of rebranded a lot of its internal services, what was kind of already out in the cloud as well. Amazon had already been providing some services to the public, and they basically took all these services, rebranded them, and relaunched them in 2006. And really, this is when kind of the software-defined data center was born. So this is a whole different paradigm. And for the first time, anybody could come and provision resources in AWS, right? And now, a lot of internal IT departments were having to compete for their own end users with AWS because it was so flexible and able to be used from just about anywhere. So it was really changing the IT industry. And so why were people coming to Amazon, or why do people go to the cloud in general? Well, it's really about agility and speed. I mean, if you think back to it, the beginning of my IT career, before, you know, cloud paradigm was, you know, ubiquitous, I guess you could say, you know, application planning life cycles were like 18 months, you know, and sometimes they were longer, like 3 years. And at least a good 3, if not 6 or even longer months of that was just dedicated to the procurement of hardware, unboxing, racking and stacking that hardware, cabling it up, and installing the necessary components for an application to even begin to function. So things like the operating system and any application binaries. And so, you know, as soon as the cloud came along, this could be done in a matter of hours, if not a matter of minutes, right? So a huge shift in the ability for people to be able to spin up and start bringing value back to the business with their applications, right? And that's really what this is all about. Furthermore, just plain old ease of use. I can teach my grandmother, who's 96, doesn't even know what a cell phone looks like, to go into AWS and provision a server. Of course, we'll never be able to use the server, but she can provision it, and that's the most important part. And along with that comes choice, right? Now we have a choice of where to go to. If you're, you know, a business unit inside of a company with an IT department, you can go to them, or you can go to AWS or GCP or Azure or any one of the other managed service providers out there to get what you're looking for, whether it's VMs or containers, whatever it is. Also with this comes flexibility and automation. These two are kind of tied together, right? With this software-defined data center, which is really what the cloud turns out to be, becomes, you know, it becomes very flexible because everything is API driven. That's what software-defined is all about. You can make a call via basically an application just like anything else and get the resources you need: networking, compute, everything you need, volumes, right? And you can do all that programmatically. And along with that comes the ability to automate, because now I don't have to go to a physical human. I don't have to go to a vendor to get anything anymore. I just make an ask of software and it returns to me the resources that I asked for. That's very powerful. With it as well, and this was talked about a lot in the beginning of the cloud, is the ability to be mobile with your application stack. Now, when the rubber actually meets the road today, there is a certain amount of vendor lock-in that comes with going to AWS or GCP or Azure, because they have a lot of proprietary services that they built to make it easier for people to consume things like, you know, databases and other services. So there is some lock-in in the cloud still, but that promise of mobility is really still there. And should customers ask for it, I think it's really something that the cloud can help iterate on and be a little bit better at in the future. Also, I think we can probably all agree that cloud architectures in general are more resilient than the old physical architectures that there were. The monolithic scale-up architectures now of days past are less resilient than the scale-out cloud architectures of today. You know, of course, it's not perfect. We're still learning lessons and we don't know what we don't know. So we do see those Netflix outages and lots of the other outages. You know, Google Cloud's had some in the past few years as well. But in general, these architectures are more resilient. And last is just empowerment, right? There's a lot of power that comes from an end user of not having to rely necessarily on someone else to provision those resources. If I'm an application owner now, I can get my resources. Sure, somebody else manages the platform for me, but all I have to do is request my resources of that platform through that software-defined data center, and I can get what I need. That's hugely empowering for me and allows me to provide a better service back to the business. Now, what are the characteristics of that cloud? Because this is pretty important for the conversation. Most people don't think about the paradigm shift when they're thinking about backups. They think about backups as something that was mired in the physical architecture. We no longer have to do it. But that isn't really true. And so the things that are different about this and the way you have to change your thinking is about how the cloud gets built and how it's kind of glued together. Right? But some of those characteristics are things like that on-demand self-service. So now people with a change in the cloud, they expect this to be the case. They expect to be able to manage their own resources, spin up their own resources. And not only that, be able to monitor their resources, right? Are my servers up and running? Are my backups happening? Can I do a restore myself? Is that restore successful? And who do I need to go to if something breaks? Right? There's also broad network access. Of course, this is, the National Institute of Standards and Technology's definition of what a cloud is. But broad network access is important because you need to be able to reach the services. You need to have the bandwidth to be able to do it. Another thing that people don't think about in the cloud that much, or people may even not understand because they don't have an IT background, is multi-tenancy, right? Logical separation and resource pooling is what makes the cloud work, right? But you don't think of it when you're going into your Amazon portal, or if you're going into Openstack, about what it is I'm actually doing. I'm drawing from the same pool of resources as everybody else. And sure, there are things like quality of service that allow me to act and feel as though I'm in my own data center, but I am not in my own data center. I am just logically separated from everyone else's resources, but we're all pulling from the same pool, right? And with that resource pooling becomes the ability to rapidly scale your applications and the resources that you need. This is why application architectures have changed to take advantage of this. I no longer need to scale up. Scaling up is very expensive in the cloud. I can just scale out, right, across x86 hardware. It gets me away from those monolithic architectures that we had before. Right? This is the way of doing application development now. Now, sure, there are monolithic applications that just can't be modernized, and those will probably never go away. The death of the mainframe's been around and talked about for years and years and years, as far back as I can remember, and I'm sure before that. Still not dead. Another one is measured service. Now, today in the cloud, this is certainly the case in Amazon. I'm sure anyone who's seen their AWS bill can certainly attest to the fact that they're very good at accounting for their services. But this isn't always true if you're inside an internal cloud. There may be no chargeback or showback inside your internal cloud, but certainly an aspect of the cloud is measured service. It's just not necessarily for everyone. And then one I like to take out of the Encyclopedia of Tobin, but I think is very important to talk about as a cloud characteristic, is that ability for the orchestration of resources and the automation of resources. These are the two things that really enable the software-defined data center. Because sure, you can have an API, but you need to be able to orchestrate the provisioning of those resources and return the resources back to the end user. And this is huge in understanding why you need to be able to back up and empower users to be able to restore their applications, and thus give the business back the best RTO that they can possibly have. So the best time to recover those applications should anything break in the cloud, because when it does break, the amount of abstraction that is necessary for the cloud makes it very difficult to troubleshoot and figure out what happened. So you need to have a plan to be able to restore those applications and do it as quickly as you can to get back to your end users. But in particular for the conversation today, I want to kind of leave out broad network access and measured service for this, because they're not really tantamount to this conversation, really. What we're really talking about today is empowering end users, the ability to understand multi-tenancy, and the scalability and automation orchestration that go along with provisioning today's applications, because they are key to not only the writing of those applications, but also the ability to spin them up and get them tested out to the public. But let's talk a little bit about the complexity of the cloud, because sure, when you go into a portal and you provision resources, it seems so simple, right? It's so simple. I think anybody could do this. But what really happens on the back end? It's a lot of planning, and it's a lot of complexity as well when you start looking at all the components that go into your cloud-built applications, right? And so if we just kind of break down this kind of chart that I put together here, when we're looking at the application layer here, that's really how we're returning value to the business and to our end users, assuming that we're not like a managed service provider, that is. But this is really where the money gets made and where the rubber meets the road between IT and the actual business itself, right, is these applications that we're providing value and serving information through. And when you're thinking about cloud applications, there are a lot of different platforms and a lot of different resources underneath those applications. But when I'm provisioning an application today, all I'm asking for are resources. I don't know where they sit physically, and I don't really care. I might care what platform they're on, because if I'm talking to, let's say, Kubernetes in this case, I'm making a software-defined definition of the resources that I need, and those are slightly different than they might be in Openstack or might be in Rev or on some other KVM-based hypervisor. And so when I'm provisioning these resources, all I really care is the fact that I have these resources. I don't need to worry about the physical infrastructure. And furthermore, if I'm looking at the physical infrastructure, or if I tried to go into a data center and identify the server where my application sits, I can't do that anymore. It's not part of my paradigm. It's about having the resources available for my application to serve data. And so behind that, yes, I've abstracted a lot of the complexity of the physical architecture itself, but that's not my care, right? That doesn't matter to me. It matters to me that it's up and running and that I can get at it when I need to scale out or when I need to spin up something new. And so really, why are these cloud applications different? This is something we've been talking about a lot internally here at Trillio. And so really the characteristics of these cloud native applications are, it's a completely new approach to building and deploying applications, because I'm writing code for my applications and I'm also writing code for my resources now. That wasn't the case before. The resources were given to me and I had to install all my code onto it. That doesn't happen. I get to write my code and my resource code the exact same way, right? That way I can spin up my whole application and get it running. I don't care where it sits anymore, right? Also, these apps are being changed very frequently, right? A lot of companies have gone to a microservices architecture when they're developing apps, or they may just have apps that sit across a lot of different VMs, right? And all those VMs are tied together into an actual application. But there's no one source of truth when it comes to the application. It's spread across many different resources that I've provisioned. And these applications do change frequently. And along with that change comes a schema change for the data that they need to interact with. You know, think about it very simply today. If I stand up a web application, I might decide to store my user information. So information about me, you know, John Tobin, and maybe just one field that says name. But tomorrow I realize I need to break that name down between first, middle, and last name. So I store those all in different fields. And then I may do the same thing with the address later on, where I'd stored it all in one field. I need to be able to break it up into, you know, the street number and then the street name and then town and maybe zip code, right? These are very common use cases, because as humans, we don't know what we don't know later on down the line, and we're constantly solving for these problems. And so whenever you're looking at the stateless pieces of an application and the stateful pieces like a database, those two go hand in hand. The application needs to know what state my schema in the database is. Even if the schema-less, quote unquote, schema-less database like MongoDB, that schema still changes in the way I store my data. And all of that together comprises my application. So it's very important to keep those in sync. Also, we just talked about it, but there's no clear boundaries anymore in applications. Nobody knows where they sit physically. It's not important. My application may stretch across the entire United States or across the entire world, right? And through load balancing and distribution of requests, I can serve those requests from the nearest infrastructure. Are also highly available and scalable, right? And that goes to speak to the change rate of these applications. Not only is the code changing, but also the physical footprint and where they sit and how many resources are available to them is constantly changing as well, and very dynamically, especially in platforms like Kubernetes and OpenShift and Rancher. There's also new languages and frameworks around these, right? With microservices architecture goes to a lot of software-defined code to, I mean, for to say something extremely stupid, but really, I mean, what I'm talking about is middleware, right? APIs. That's what enables that microservices architecture, is the ability for us to break down the application and constantly be talking through APIs. So we don't have to worry about monolithic applications. We have the ability to change things very rapidly, which leads to the point that they are highly automated and API driven, right? So that's how you get away from a monolithic application, by breaking it up and providing that middleware so that the pieces can talk to each other. They're also policy driven and multi-tenant, right? That's very important for these applications to know, where do I lie? How can I authenticate myself and make sure that I'm interacting with the right tenant and that my application is secure? But that doesn't equal the days of yore when, you know, a lot of the backup platforms were originally architected. And the reasons why that data protection technology isn't working is because it was built on a lot of disparate technologies, right? We had originally designed an agent maybe, and now we're trying to keep pushing that agent forward because physical infrastructure isn't going away. There always needs to be a server behind, but the physical infrastructure is just dumb infrastructure these days, right? There's also an application and operating system dependence a lot of times with traditional backup technologies, because they're using agents, right? And they may be integrated into the applications. But the new way of doing things is to do things in a standard way that doesn't require me to bolt into the application anyway, but allows me to get the consistency that I may need, right? All of this is changing today in the cloud. Also, applications used to be very siloed and monolithic, so they were very easy to manage before with agents because they were mired to physical infrastructure. I can see, I can touch, and the entire application is defined inside of that one server, right? That's very easy to back up. They didn't have a changing footprint a lot of the time, right? These infrastructure, this physical infrastructure, like I said, it was scale up. It was about more CPU, more memory. Let's upgrade the server so we can get faster and get more resources. Today, it's all about scale out. So the footprint is changing rapidly, and trying to manage that footprint with an agent is very difficult. It's also very difficult to understand which application I'm backing up with that agent, as everything is scaling out quickly. And also, the traditional paradigms for backup assumed that the config for the application was contained inside the volumes on that host, right? No longer is that the case today. The configuration, the state, and the entire application is contained across many resources now. And those are very hard to back up and to be able to restore just by using an agent, because a platform is now orchestrating it. As well, inside of the cloud or inside of OpenShift, right? Agents break down because they have a very large CPU and memory footprint on every single resource they touch, right? And so this becomes very disruptive in the cloud, because I have to actually acquire more CPU and memory just to dedicate to that agent, and it only backs up one resource, right? It's not backing up many VMs, it's backing up one VM, right? Or one physical node, and that's tearing away some resources from my cloud. And so if you're looking at cloud backups, well, cloud backups are also they're very complex, right? And so are the applications. And so self-service is necessary. If I'm an end user, I want to make sure that I can manage all my own resources, and that includes backups. I want to know if my VMs are up and running, but I also want to know, are my backups completing? Can I restore this application? And I want to be able to do it in my pane of glass. I don't want to have to go somewhere else. I already know this one. So if I can integrate in it, that's all the better for me, right? And not only that, when I'm backing up, can I restore things like my VMs? Or can I restore my containers into OpenShift along with my deployments and things like that? Also, am I getting my volumes, right? Is all my data there across my entire application, no matter what resource it's lying on, no matter what replica set it's on, or where my pod spans? Can I get to those PVs, right? Also, my network plumbing is very important. I have to get to my application. I need my SSH keys. In OpenStack, I need my security groups. Otherwise, I can't hit my VM, right? These are all important to RPO. And furthermore, permissions, right? in multi-tenancy, it's really important. So permissions and multi-tenancy kind of go together in this conversation, right? You're talking about, can I restore it to the right space, and is it secure when I restore it? Also, do I have my application? Is my application actually going to be back up and running? And as well, my additional metadata is particularly important in platforms like Kubernetes, because I have things like secrets. I have config maps. I don't just have it's not just about PVs, right? It's about my pods, my deployments, my replica sets, all of my RBAC policies. I need to know that all that stuff's secure. In traditional backup paradigms like VM-based backups, or even storage-based backups, or physical node agent-based backups, break down on these other resources, right? And so I need to integrate at the platform level, because you can imagine that if you were standing inside of a bunch of trees and you're looking up, you can't see the boundaries of the forest. But if you're flying over that forest in a plane, you can look down, you can clearly see where the boundaries of that forest lie, where the next forest boundaries lie, right? And that's all about what platform integrated backups are all about, is being able to see those boundaries, being able to see those resources and back them up. And that's what allows you to have the best RTO when you're going back to your business to restore these applications. And with that, please ask us some questions, join the discussion. Kev, how are we doing?
Yeah, thanks, John. That was very, very enlightening, and I hope our attendees enjoyed that. We do have a couple of questions. See if we can get through them. I appreciate the time. It looks like we almost ran to time. I thought that would be an actual record. But there's one question here. At the very least, we'll get through this one. It says, we're still developing out our cloud journey or cloud strategy, migrating our apps from, it says VMware to Kubernetes. So it's not like they're going cloud native. At what point do we consider cloud native data protection? Do we have to run multiple backup strategies?
That's a pretty good question. So multiple backup strategies. So no, you don't have to run multiple backup strategies. I think what we're trying to get at in this presentation that may not have hit home is, obviously this is a platform specific conversation, right? When you're talking about an integrated backup platform, you're talking about one that's specific for the particular platform you're in. And so, when you're in Kubernetes, it's about being native to Kubernetes itself. So there aren't multiple backup strategies, there's only one. And when you're looking at a Kubernetes integrated backup platform, in particular, what you're looking at is an actual application that runs inside of Kubernetes that your developers can interact with during their development cycle, just like they interact with other Kubernetes resources. So doing things like kubectl get backup or kubectl create backup, right? To be able to back up their applications, and no matter what, being able to define those applications based on the way that they're used to developing, whether it's they deploy a custom application and use labels, or they use things like Helm charts, or they're even more mature than that, they're using operators inside of Kubernetes. No matter what, you need to be able to back up all of the resources that are defined in those methods for deploying your applications so that your business is protected. And you can use the rollback functionalities inside of Kubernetes to do not only the rollback of the application, which is very mature in Kubernetes today, but also the rollback of those PVs, because what you'll find is that the more often you release code, the more likely it is that you'll corrupt your PVs. Mm-hmm. I don't know if you have any additional thoughts there, Kev.
Yeah, I mean, obviously, there are going to be a number of people who are on this cloud journey, but I think the point as well to make, and what you were saying, I think the additional point is everything's on that migration journey. It's not just the infrastructure that's changing, the apps that live on those platforms change, but of course how you manage those platforms, holistically has to change as well, and backup has to evolve into this world as well. So I think there is a world where you will be running your existing backups for your existing estate, because guess what, your business needs to be able to function in the event of any issues. And just like your new cloud world, that's going to be in the same place in terms of you have to recover those apps, when needed. So absolutely, and certainly I think the likes of Trillio on these platforms, I think that they're so part of that particular platform that they just add additional functionality, which we know and love as data protection, that it becomes less cumbersome. And I think that's one of the more I guess points that people miss on this journey, because it's always seen as a heavyweight action. It's always seen as a backroom IT function, and the way we approach things, certainly how you would expect to approach things in a cloud native world, is more lightweight and more part of the process flow.
Mm.
And another question. I'll go for the one that's coming on the multiple screens now. So I'll go through the Q&A one. So it says, how do we protect the Openstack configuration, Keystone, and database through Trillio?
Okay, so that's a control plane question inside of Openstack. Mm-hmm. Well, the design of Trillio was to be able to take a VM's view of Openstack and its resources. So that's really the way that we back up Openstack today. Now, when it comes to the control plane, I think traditionally the way people have approached that in the past, that was releases of Openstack before, was doing a lot of database backups, right? So backing up the MariaDB database, which contains a lot of the information that you'll need to be able to restore your Openstack control plane. I think a lot of that has changed, Kevin, and you have more expertise here than I do when it comes to the Openstack control plane. But my understanding of the way a lot of people are doing it today is now with triple O, things like Red Hat Director or Juju Charms with Canonical, is they're looking more to the Openstack control plane as almost a stateless piece. And that if something does happen there, sure, if I can fix it easily, I'll do that. But otherwise, my strategy is kind of just to roll forward into a new OpenStack deployment, because it's become much more automated in the deployment of my cloud. But I'd be interested to hear your thoughts there.
Yeah, precisely. I mean, that control plane itself is more of it's almost like a place where it's kind of stateless, but it has stateful entities. Mm-hmm. But the interesting thing is, from the Trillio side of things, is because of our application and metadata view of the world, we technically take out the important pieces out of the database. So when people are asking specifically about backing up the database of OpenStack, technically, if you purely took a backup of the database of OpenStack, a recovery of that database doesn't make sense, because it's a point-in-time view of the estate. It manages the unique identifiers of all the components of the cloud. So if you recovered something from 8 hours ago, the state of those IDs within the individual tables, go down to that kind of level, it just doesn't make sense. Mm-hmm. But what we do in Trillio, the process of where we take the metadata, technically, at that point, if you really wanted to boil down the functionality, when we're calling an API to grab data, technically, we're extracting the important rows of data out of the database and storing them as part of the workload. So we technically do that, but then it comes back to this point that you've just made, John, in terms of the actual components of the infrastructure itself. A controller node, technically they're just a service, and recovery of them, is a number of ways. Absolutely. If the control plane was running on virtual platform, so very common, is to run the control plane of, say, a Red Hat platform on Red Hat virtualization, we can take a copy of that control plane, and we can recover that particular control plane. But the alternative view is like what you've just said, John, is because it's kind of stateless, and we ultimately, the important part of OpenStack isn't actually OpenStack itself. It's actually the workloads that run on top of OpenStack, which are technically the things that are making your business money. That's the important thing. But the recovery of the control plane is just a multiple strategies, but it has less of a reason to actually back up those individual components of Keystone, of the databases. When we extract the important stuff around the app, which you can recover into a new Openstack and continue your journey through using that new cloud with your existing recovered application. So it's a different view, but that's how we tackle things. Mm-hmm. The last question, I think, would just I said we're out of time, but I just wanted to get this one. I find actually quite interesting. It says, does taking a more cloud native approach affect RPO and RTO? And I know this is kind of interesting, considering that I know, John, you've done a talk on RPO and RTO a good few weeks ago, but it's interesting it's come up today again. So what's your thoughts?
Yeah, I think it does. There's a lot of different opinions on this. I think it does because the picture I was trying to paint in this presentation is that applications are infrastructure now. They are infrastructure and they are application code, right? And all of those things are part of an application's ability to spin itself up, and they're hard to decouple now as well. Right. So when I'm provisioning my application and when, I'm going to roll it out, whether it's through like continuous deployment or it's some sort of manual method, right, I'm provisioning the infrastructure a lot to test. And I'm also rolling out the code all at the same time and kind of en masse. Right. And, traditionally in the cloud, a lot of people say, well, it's on the applications now to do their own backups, do whatever they need to do to be able to restore their application. But the thing is that the platform is so integrated into that application now that the ability to be able to do a push button roll of that application should something go wrong. Say even the OpenStack cloud goes down, well, my secondary cloud, I can just roll my application into there and get it back up and running. Because the thing that's really difficult, Kev, when something goes wrong in the cloud is trying to figure out what went wrong, right? How do I restore this? I don't even know what happened. Right. And so there's so many different layers to troubleshoot on. That's the hard thing. And getting it back up and running as fast as you possibly can through something like push button that's integrated into the platform is going to get you all your resources back. So your networking, your permissions, your VMs or containers, right? Any sort of config maps or services that you need to be able to hit that application all automatically back and running with your PVs or your volumes back to that point in time too, and the application back to its state at that particular time. Trying to figure out what the application state was and where my backup for my volume lies and which volume I need to go back to is really difficult. But if you got it all together and you can hit one button and restore that application state at the particular point in time and its volume at that particular point in time, like that to me is hugely powerful to the business and really reduces downtime. So I guess what I'm trying to say is I can imagine drastically reduced RTO if you have a platform integrated backup.
Yeah, I agree. And I think I just wanted to, add to that kind of point in the fact that I think a lot of these conversations, again, it's all about that transition from one type of view of the landscape to another, in a cloud-centric view of the world, application, architecture and the actual app developers themselves actually become part of these discussions. It's no longer just an IT function to solve. It's the cloud paradigm itself actually pushes a lot of, I wouldn't say responsibility, but it's a joint responsibility for the applications themselves, and in order to function as the business expects. So I think that's an interesting point in the fact that cloud native pushes the conversation up the stack towards application developers as well.
Mm-hmm. Yeah. I think it pushes it closer to the business, which is where it should lie, right?
Yeah, absolutely. I know we've got more questions, and I do apologize, but we are very much out of time, and it definitely wasn't my fault this time. But I would just like to thank everybody's time. Just very quickly, for the interaction. Thank you very much for everyone who's sent in some questions and the like. The winner of the $50 this week, we've chosen Ben and Ma. Sorry if I have pronounced your name wrong. I'm from Liverpool. I don't pronounce anything correctly. So, but yeah, congratulations, and join us next time for the top 10 considerations for selecting data protection for your Kubernetes applications. So thank you very much.